So yeah, I hate I hate the titles and thumbnails that this channel uses because they sound very, very clickbaity. But the channel itself, Destiny, is actually, from what I've seen so far, is very good. Very well researched. Um, I have yet to be disappointed. I feel like every single time I click on one of their videos, it's like, okay, is this the one where it's like, oh, it's one of those space channels? But it's actually very good. Exactly. If out of sight, out of mind. You know what I mean, Bridges? I would love to draw more. Yeah, yeah, I would love to draw more. My tablet is literally just hanging out in a drawer right here, right in front of me. It's right here, right beneath my hands. Oh well. Anyways, let's check out this video. Because I really like this channel and I like space stuff. And I would love to learn what new Jupiter stuff they've learned. Yes. Okay, here we go.
In the vast reaches of our solar system, Jupiter reigns supreme as a gigantic mystery, captivating scientists and astronomers for centuries. Just when we think we understand the gas giant, this celestial behemoth shatters our assumptions. With its blend of unpredictable and often hostile behavior, mesmerizing storms with winds up to 640 kilometers per hour, and the enshrouded mysteries of concealed metallic oceans within its core, Jupiter still leaves scientists puzzled. Join us on an extraordinary journey as we delve into the depths of this enigmatic world, uncovering its secrets.
Hell yeah. Very high production channel too, which I like. High quality
Decades of
resources.
extensive studies have demonstrated just how remarkably intricate Jupiter is. Just recently, 12 more moons orbiting the gas giant have been discovered. The total number of satellites around Jupiter is now 92, more than any other planet in the solar system. The latest moons discovered have sizes ranging from 1 to 3.2 kilometers. A majority of these moons have extensive orbits, with 9 out of 12 taking over 550 days to complete one revolution around the planet.
So cool.
Scientists believe that because these distant moons move in the opposite direction of Jupiter's rotation, they could be captured asteroids.
That's cool.
It's been widely believed that Jupiter acts as a protective shield, safeguarding our planet from threats from outer space. In the past, astronomers have even suggested that this was one of the reasons life got a chance at evolving on Earth. But recent findings cast doubt on Jupiter's role as Earth's celestial guardian. Long-period comets, which originate from the distant regions of the solar system and take millennia to orbit the Sun, typically enter our vicinity. However, thanks to Jupiter's gravitational influence, most of these swiftly moving icy objects are flung away from the solar system before approaching Earth. So the chances of long-period comets colliding with our planet are extremely rare, occurring over millions or even tens of millions of years, and Jupiter's presence plays a crucial role in...
You know, it seems like every couple years there's a new headline saying like, oh, a giant asteroid on its way to Earth. It's probably going to miss us, but it's going to get kind of close. Have you guys noticed that like there's always new articles about that every couple of years? All the time. All the time.
Or even tens of millions of years, and Jupiter's presence plays a crucial role in shielding Earth from these potential impacts. However, the gas giant's gravitational forces have both positive and negative implications for life on Earth. On one hand, its immense gravity prevents nearby space rocks from accumulating and forming into a planet. This led to the formation of the asteroid belt, a collection of numerous small debris fragments scattered between Mars and Jupiter.
They're so cool.
But nowadays, the gas giant's gravitational pull continues to influence asteroids, causing some to deviate towards the Sun.
All right, recording. That sucked. I'll rewind it to, like, does this seem right? this, like 2.5 minutes in. This seemed. Did you guys recognize this? I just had to reset my modem. You don't remember this? Okay. How about this? Do you recognize this? Alright, we'll watch from here then. Okay. Thanks, internet. Thanks for making my job so easy. Okay, let's get right back into it then, I guess.
Cast doubt on Jupiter's role as Earth's celestial guardian. Long-period comets, which originate from the distant regions of the solar system and take millennia to orbit the Sun, typically enter our vicinity. However, thanks to Jupiter's gravitational influence, most of these swiftly moving icy objects are flying.
I'm sorry, you're gonna hate me, but I'm gonna grab a snack. Okay, I'm sorry. I'm back. I'll mute the sound while I'm nibbling.
Flung away from the solar system before approaching Earth. So the chances of long-period comets colliding with our planet are extremely rare, occurring over millions or even tens of millions of years, and Jupiter's presence plays a crucial role in shielding Earth
butter
from
chicken
these
and
potential
chicken
impacts.
Korma with rice.
However,
mixed.
The gas giant's gravitational forces have both positive and negative implications for life on Earth. On one hand, its immense gravity prevents nearby space rocks from accumulating and forming into a planet. This led to the formation of the asteroid belt, a collection of numerous small debris fragments scattered between Mars and Jupiter. But nowadays, the gas giant's gravitational pull continues to influence asteroids, causing some to deviate towards the Sun. This change in their trajectory increases the odds of collisions with Earth, and we've already witnessed it in the past. In 1770, Lexell's comet passed just about 1 million miles away from our planet, an extraordinary proximity on an astronomical scale. Scientists believe that this comet had initially come from the outer reaches of the solar system and had a close encounter with Jupiter that redirected its path towards Earth. After completing 2 orbits around the Sun, the comet returned to a point of close proximity to Jupiter 9 years later, which subsequently ejected it from our solar system. The Jupiter shield theory, supported by previous computer simulations, suggested that the gas giant ejects countless long-period comets out of the solar system. And this theory even predicted the comet Shoemaker-Levy 9 striking the 5th planet in 1994. But computing resources weren't as powerful as they are nowadays, and scientists had to make a lot of calculations. Today, we have data that includes a greater number of short-period comets and near-Earth asteroids that intersect with Earth's orbit
so rare
compared to long-period comets,
to have
and new
life
simulations
anywhere.
demonstrate a different picture. Jupiter's influential gravity interacts with the asteroid belt, causing gravitational resonances that clear out rogue asteroids and redirect them inward. Collisions between asteroids can also contribute to this process by dispersing rocky fragments into resonant zones. The inner edge of the asteroid belt is particularly affected by a phenomenon known as secular resonance, which drives material into the inner solar system. Jupiter's current mass allows it to both redirect comets towards Earth, as seen with Lexell's comet, and effectively remove them from the solar system. If Jupiter had only 1/5 of its current mass, it would still destabilize comets, but lose the ability to remove many of them, leading to a higher impact rate on Earth. The frequency of impacts plays a crucial role in the long-term evolution of life on a planet. Earth's geological record indicates that an impact rate of 1 major collision every 100 million years provides enough time for the biosphere to recover and thrive. However, a higher impact rate occurring every few million years could devastate the planet, hindering the development of a new biosphere. Some scientists believe collisions with Earth is also how water was brought here. But what about water on Jupiter?
Oh, that reminds me. They found, I mean, it's probably more than one meteorite, but one meteorite in particular, I was reading about it recently. It had like amino acids and stuff in it. So like, that's incredible. That is absolutely incredible. A meteorite with amino acids in it, that's a big deal. That's a really, really, really big deal. I think it was in Australia. I might be wrong. Correct me in the comments if I'm wrong. But like, I just think that is so amazing. I have no idea. I would love to believe that there's like crazy life out there. Just, and I'm not saying there's no life out there. I'm just saying it's like a 1 in a quadrillion bajillion chance that life can form out there. Like the video that we watched before talking about all the different systems out there and all the different star systems. It's pretty incredible how lucky we are to be where we are. You know? Artificial? Well, who knows? I watched a video a while ago about why carbon is like the dominating element when it comes to life compared to silicone, even though I'm pretty sure they have the same amount of valence electrons and they're all open and ready to connect to stuff. Like silicone, I think, is the most common element, or one of the most common elements on Earth. Not the most, but one of the most common elements on Earth. And the main reason why carbon is the main component to life is because it has one less ring, and so it's significantly more stable. Like all of its valence electrons are just on one ring, so there's not like, if any of you guys understand like atomic structure, there will be like as you go through the periodic table of elements, there's more electrons on the outside which connect and link with other elements to form different chemical compositions. And carbon is just insanely stable. There is, however, like there are some things made out of silicone. Like there are certain sea sponges in the ocean and their primary component is silicone, which is incredible. And they kind of form like little cages. They're really cool, but it's like so rare. But every living thing, I'm pretty sure, just has carbon as like one of their base elements, which is really cool. Sand is silicone for the most part. I mean, there's other elements mixed in there as well, but it is primarily silicone. And if you look at sand under a microscope, you'll find the most unbelievable crystalline structures. It's so cool, especially if you see sand from all over the world. It's all so different. It's amazing. Leftover civilizations that went extinct? Maybe. It could be. The universe has been around for billions and billions of years. Well, like 14 billion? That's a lot of billions in the great scheme of things. I also think it's just as likely that there was life before as it is likely that we are the first life. Like the first real, like, intelligent life. I wouldn't doubt that either. Because the universe's development, from what we theorize, is that for a long time, everything was just a big fucky-wucky mess. Really hot, nothing really solid, and then as time goes on, things start to find their place, and they get their rotations going, and it's interesting to speculate how the universe has expanded and grown into what it is. And obviously, you know, all stars have like a lifetime. They will eventually go supernova or just implode or become a brown dwarf, and they're pretty stable. But I still find the whole silicone carbon life building block thing very fascinating, and it would be more, I should look into see if there's more silicone based life forms on Earth rather than those sponges, because I think that's fascinating. I remember I saw that video in the sidebar and I thought, huh, that's true. Why aren't there more silicone based life forms? You know, like it works, but just carbon is just so gosh darn stable. It makes sense that it was more successful. Oh, it's incredibly difficult for organics to travel the universe, let alone like even just the galaxy or even the solar system. It's so hard. And then there's also like around our solar system, there's like a field that would make it very difficult for us to even escape our solar system. Crazy stuff. Oh, hey, how you doing? Sup, Galactus? Selenium sulfide in head and shoulders. Arsenic, way too poisonous for that. Yeah. Yeah, arsenic, very safe. Eat it. Don't eat arsenic. That was a joke. All right, let's get back to the video.
Water vapor was first detected on Jupiter in 1995. This discovery was made by the Galileo spacecraft, which conducted extensive observations and measurements of the planet and its moons. The onboard instruments of the Galileo spacecraft, particularly the near-infrared mapping spectrometer, detected the presence of water vapor in the planet's atmosphere during its close flyby. But recent data demonstrates water makes up approximately 0.25% of Jupiter's atmosphere above the planet's equator. While this may not sound like a lot, it's actually an immense amount of water. Jupiter, probably the first planet to form in our solar system, contains a significant amount of gas and dust that didn't become part of the sun.
People on TikTok convinced people to frickin' eat Tide Pods. I'm convinced it's all just a thing trying to kill off stupid people. You don't drink borax. They use that to, like, clean stuff and kill ant colonies. The story of the expedition to retrieve samples of a possible interstellar... I heard about that, but I haven't actually looked into it. Oh, I'm glad you feel better about life. That's great, Shadow Steel. It's awesome to hear. We've always got interesting topics going on, even if they are stupid. These are good, though. These are good topics. Yeah, natural... Yeah, Darwinism. Exactly.
Knowing just how much water is locked up in Jupiter is crucial for scientists studying the formation of the solar system. In recent years, a team of researchers used telescope data to discover a substantial presence of water within Jupiter's famous Great Red Spot. Launched by NASA in 2012, the Juno spacecraft currently orbits the gas giant, taking close-up pictures of its clouds. Equipped with advanced instruments, the spacecraft has now revealed even more evidence of water on Jupiter. Because this massive gas giant holds more than double the combined mass of all the other planets in our solar system, even small fractions of water on such a massive planet would amount to a significant quantity, far exceeding the amount of water found on Earth. Water in the gas giant's atmosphere is also the reason why Jupiter, just like Earth, has its own mesmerizing displays of lightning 100 times brighter than terrestrial lightning and peculiar hailstones. Lightning has been detected in the planet's water clouds in the past, where water droplets collide with electrically charged ice crystals. But the Juno spacecraft has also spotted dim lightning at higher altitudes in the atmosphere, where the temperatures drop to approximately minus 87 degrees Celsius, too frigid for water to exist in its liquid state. So how does lightning happen under such conditions? The answer to the mystery lies in ammonia, a remarkable component in Jupiter's atmosphere that serves as a natural antifreeze. In the upper atmosphere, water ice crystals combine with ammonia vapors and melt. These water ammonia droplets then collide with additional ice crystals from below, creating an electrical charge that generates lightning. Below the ammonia ice clouds, the ammonia water droplets undergo continuous growth until they become too heavy to remain suspended in the air and resemble large hailstones like we have on Earth. Scientists believe that these mushball-like objects descend deeper into Jupiter's atmosphere. But now, let's travel even deeper into Jupiter's innermost layers. Previously, it was believed that our solar system's giant worlds all have a rocky core. This was the accepted theory for a very long time, but recently, scientists have started to doubt this theory. Using Juno's orbit data, scientists are still studying how matter is distributed inside Jupiter, and recent discoveries have unveiled an unexpected mystery lurking within the gas giant's core. Jupiter's core has extremely high pressures, much greater than on Earth, and temperatures as hot as 20,000 degrees Celsius. To understand these conditions, scientists use powerful lasers to compress samples and mimic the planet's pressures in a laboratory. The Center for Matter of Atomic Pressures at the University of Rochester is at the forefront of this research. The density of materials in Jupiter's core depends on their composition and physical properties. And just recently, scientists have discovered that Jupiter's core is not as compact as they thought it was. Deep within its inner regions, only 18% of the material is rocky. Jupiter is predominantly made up of hydrogen, accounting for about 90% of its composition, along with roughly 10% helium and trace amounts of other elements.
Yeah, I thought it had a liquid
In the
core.
outer layers of this gas giant, hydrogen exists as a colorless and transparent gas, in the same form as it exists here on our planet.
That's cool.
As you descend deeper into Jupiter, the increasing atmospheric pressure transforms hydrogen into a bizarre, dense fluid that conducts like a metal.
Imagine how cool it would be if there was some sort of like impervious ship that you could take to go through Jupiter and like look out windows just to see what the heck is going on out there. Even if it was just like, even if it just looked like that glittery water shit. It would be so fascinating. And I've said this before, I think the only reason why I would actually want to physically go to space is if I wanted to die in space. I I have this sick thought where I'm like, what's it like to go into a black hole? Like, I would expect that to be the last thing I did, but like, I wonder how awful and strange it would be to just get sucked into a black hole. That's like my morbid space thought. Flying it into, yeah, isn't it? It's so cool. It would be so cool. Oh, it's a gravity thing. It's still dense enough, and a sphere is kind of like the shape that ends up being, which is why like all the stars are spheres. Most planets are pretty much just spheres. It's stable enough, and it's an even distribution on the outside, so there's no like real discrepancies in the gravity from their own mass. Like, yeah, we got mountains and stuff, but it's like within that range that it's not crumbling in on itself. So it just sort of forces itself to be in a sphere. Going into a black hole, you live forever? I mean, it might feel like forever. Who knows? I don't know. I feel like I have seen the core. I don't know. A planet of squares! I feel like that would eventually crumble in on itself. That would be interesting, though. I would like just like find like a solar system that has like planets all the shape of different dice. That would be cool.
So, what is this substance? Approximately 10% of the way towards Jupiter's core, along its radius, the immense volume of hydrogen gas that forms the planet's atmosphere becomes compressed into a unique form known as liquid metal hydrogen. Liquid metallic hydrogen possesses properties similar to water, with low viscosity, excellent electrical conductivity, and efficient thermal conduction. Within Jupiter, this abundant substance transforms the planet into one huge generator. On Earth, elements exist as solids, liquids, or gases, depending on
But then there's
temperature
also
and pressure.
plasma.
While hydrogen is typically a
another
gas
state.
on our planet, it can be compressed and cooled artificially to become a liquid or solid. However, even in these states, hydrogen retains its non-metallic nature, poorly conducting heat and electricity. In contrast, metal...
Wait a second. Hydrogen in its non-metal... What about metallic hydrogen? Could I own metallic hydrogen? Metallic hydrogen and hydrogen. buy metallic hydrogen? How do you get metallic hydrogen? To develop metallic hydrogen, Silvera's team squeezed two opposing heavy-duty diamonds together to compress gaseous hydrogen, and then they transitioned it into its liquid state by lowering the temperature. Hydrogen liquefies at a temperature of negative 252 degrees Celsius or negative 423 degrees Fahrenheit. So in 1996, a group of scientists at Lawrence Livermore National Laboratory reported that they had serendipitously produced the first identifiably metallic hydrogen for about a microsecond at the temperature of thousands of Kelvin, pressures of over 1,000 GPa. So basically, no, I can't have metallic hydrogen. That would be the star of my mineral collection, let me tell you. So for those of you who don't know, I collect crystals, fossils, metals, meteorites, tektites, stuff like that. I'm really interested in chemistry and geology and space. And so I like to collect really weird things. Specifically if they have very interesting chemical formulations, or if they have a weird just a weird composition, or if it's rare, it's oh, this only comes from there, this only comes from there. I'm working on building up my rare earth collection. But I got metallic hydrogen. Yeah, I got big chunks of copper and galena and just a bunch of random stuff. I really want a metal collection. I know there's crazy silvers that look like evil trees and stuff that you can get. I really want to get a hold of one of those. It's just, the really nice specimens are thousands of dollars, and I'm not ready to spend that right now. I don't have any pictures on my Instagram, no. Maybe one day. Maybe one day. But I just really like that kind of stuff. Yeah, apparently I guess metallic hydrogen is not going to be on my list of things in the near future. Oh, shit. Makes me a little sad.
Excel at conducting heat and electricity due to their atom arrangement. Deep within the gas giant of our solar system, hydrogen undergoes extreme temperature and pressure, which allows for peculiar states, including liquid metallic hydrogen. Hydrogen atoms, under these conditions, shed their electrons, resulting in a mix of free-floating hydrogen nuclei and electrons. This electron mobility resembles metal behavior.
Okay, that's really cool.
There's a theory that Jupiter's core might be filled with vast oceans of this substance, and based on previous estimations of the Jovian core's mass, it could be 12 to 45 times more massive than our planet. A 40,000 kilometer deep layer of liquid metallic hydrogen, combined with Jupiter's rapid rotation of about 10 hours, generates a colossal magnetic field that spans an...
Jupiter rotates every 10 hours? What the That is so fast! That's insane! Holy moly, it's so big. That's so fast. Oh my gosh. Wow. Okay.
Astonishing distance of 725 million kilometers. This magnetic field stands as the largest in our solar system, and it contains mysteries of its own. Exploring regions more than 320 kilometers down into Jupiter's atmosphere, scientists have identified a newfound area known as the Great Blue Spot, not to be confused with Jupiter's Great Red Eye Storm,
which is disappearing.
Researchers knew that the Jovian magnetic field was complex, but they had no idea just how weird it was. And it has something to do with the Great Blue Spot.
Yeah, I was going to say, there's little
lines. The
Jovian
magnetic field is 20,000 times stronger than the Earth's magnetic field. But now, scientists have discovered that its strength is volatile. Unlike the Earth's dipolar magnetic field, the gas giant's magnetic field originates from a wide area in the northern hemisphere and re-enters near the South Pole, Researchers have also identified a concentrated region just south of the equator, the Great Blue Spot. It's like a second Jovian South Pole located near the equator.
That's a
The
nightmare.
colossal storm that's raged for centuries is probably caused by the presence of high concentrations of ammonia in the atmosphere.
Ew.
The intensity of the magnetic fields in the Great Blue Spot undergoes fluctuations of up to 1% per year, strengthening and weakening across different regions.
That was so
By the
cool.
end of the extended
Love the
Juno
different
mission in
lines
2025,
of movement.
scientists will have ample evidence to evaluate their hypothesis.
Yeah.
As
That's
research
cool.
continues, we're going to encounter new mysteries about the gas giant. Since the Great Blue Spot and the Great Red Spot are located at the same latitude, it's possible the two phenomena are somehow connected. Gas giants are typically characterized by their high temperatures, especially in their upper atmospheres. In our solar system, there are two such giants, Saturn and Jupiter. However, Jupiter doesn't have a consistently high temperature throughout its entire structure. The solar system's largest planet is mostly known for its massive storm, twice the size of Earth, the Great Red Spot.
It used to be 3
But the
times the
gas
size
giant
of Earth, right?
has other spots too. The Great Cold Spot is nearly as large, and scientists have been observing this phenomenon for years now. At its largest, the spot is approximately 12,000 by 24,000 kilometers across. But unlike the famous red spot, this intriguing atmospheric feature stands out as a region of significantly colder temperatures compared to its surroundings, about 200 degrees cooler than the surrounding atmosphere. The Great Cold Spot is volatile, disappearing and reappearing from time to time. Scientists have discovered that this phenomenon's recurrence is triggered by the planet's auroras. Because of this correlation, the spot's age is about the same as the age of Jupiter's polar lights, which is in thousands of years.
Okay.
Jupiter's auroras, similar to Earth's, are produced by
beautiful, by the
charged
way.
particles interacting with the planet's atmosphere near the poles. However, the gas giant's polar lights are more stable and intense, as they receive particles from both its moons and the sun. New findings indicate that these auroras transfer energy to Jupiter's atmosphere, creating a temperature difference between the upper and lower regions. This temperature contrast leads to the formation of a swirling vortex, resulting in a cooler patch that is distinct from the aurora and its surroundings.
Well, that makes sense that it would be incredibly stormy if there's a lot of different temperature variations. That's kind of similar to like here on Earth. Like, isn't it like tornadoes are formed by, hot air has one pressure, cold air has another pressure, and then if they like kind of mix it, it creates like a tornado, right? Like that's one, if not the only way that like tornadoes form, if I recall correctly. Hydrogen dioxide. I got a ton of silicon dioxide. Is it the core that rotates the rest of the planet, or is the sun rotating Jupiter? Yeah, no, I believe Jupiter's core is making it. But the thing is that like similar to the sun, because it's not a solid, there are like different rotations going on it. So like if you look at the lines of Jupiter that go down, like some are going that way and some are going that way. Whereas the sun, the core is going one way and then the two poles are going the other. So like every like 11 years or something, when it goes like around completely, like I think it's like a few times, it like creates a giant solar storm, like a solar flare that comes out every 11 years or so. Was it 11 or was it 28? I don't remember. It's either 11 years or 28 years. I don't remember off the top of my head. But it's something like that. Something like that. And there was one giant solar storm caused by it that fucked with our electronics on Earth. And gosh, I remember watching a video about it. And people were like receiving signals through the air. Like they were getting crazy signals from other people like sent to their devices that they weren't technically supposed to be receiving and stuff. It was I'm not explaining it well, but it was very fascinating. Oh yeah, solar flares. Yeah, I would love that. A massive solar flare could destroy a lot of technology on Earth. Could knock out a lot of our tech, like completely fry our electronics. Like there is a lot of stuff that is solar flare proof. It's been protected, but a lot of stuff that's like all all the cars that heavily rely on their electronics, fried. Absolutely frickin' fried. Scrap metal. You know, and it would be way more radioactive outside, that's for sure. Like, there is radiation that comes to Earth from the sun, which causes, like, you know, damage to your DNA if you spend too much time outside, but with a solar flare, it would be way worse. You would not want to go outside during a major solar flare. It would be a bad time. Yeah. I mean, I don't know. I feel like Earth is probably still our best option. I think we should take care of Earth. I don't think that the better option for humans is out in space. I think we need to take better care of Earth. Like, we've evolved to live here. We just have to not make ourselves go extinct. Well, I don't think that humans would have a better chance out in space where we have to build everything from scratch when we already have everything we need here. We just have to take better care of it. Well, the sun is going to die in like, what, 4.3 billion years? Humans are not going to be around then. At least not in the state that we are right now. Maybe by that point we will be intergalactic. Who knows? Who knows? Maybe we will go extinct sooner than later, or not. I don't know. I don't know what the future holds. I wake up, I watch my YouTube videos, I eat food, I work, I go to bed. I don't really think about the existential crisis that is our species' extinction on a daily basis. It's not something I think about. Well, I do think about it, but not every day. Either way, let's finish this video. Wings? Oh, I can see it's having mechanical wings. I don't know about wings. There aren't exactly a whole lot of mammals out there that have more than, 4 limbs. We're not bugs.
Earth also experiences similar effects. However, the combination of factors like Jupiter's rotation that helps retain heat in specific areas and the varying nature of these events makes the occurrence of polar lights on our planet less consistent.
I got all sorts of other shit on my brain.
Another discovery made about the gas giant was that, contrary to common belief, Jupiter doesn't actually orbit the Sun. The center of gravity between Jupiter and the Sun does not reside within the Sun itself, but instead exists at a specific point just above the Sun's surface. In space, where a smaller object seemingly orbits a larger one, both objects actually orbit around a combined center of gravity. Consider Earth and the Sun, for instance. In this case, the center of gravity is so close to the center of the larger object that its impact is hardly noticeable. The larger object appears motionless, while the smaller object traces a seemingly perfect circular path around it. The same happens when the International Space Station orbits the Earth. Both the Earth and the ISS orbit around their shared center of gravity, even though our planet seems to be completely stationary, while the ISS appears to orbit the Earth in perfect circles. This principle generally holds true for most planets in our solar system. Even Saturn has negligible influence on the Sun's position in space. However, as the difference in mass between the two objects decreases, everything changes. In the case of Jupiter, its immense size causes the center of mass, known as the barycenter, to exist 1.07 solar radii away from the Sun's center, approximately 7% of a solar radius above the Sun's surface. This means that both the Sun and Jupiter orbit around this particular point in space.
Okay.
As the voyage of discovery continues, the enigmatic depths of Jupiter hold even more surprises yet to be unveiled. Stay tuned here to be the first to witness cosmic newfound wonders, and thanks for watching.
I just have a really hard time coming to terms with the fact that AI is an inevitability. And it's like, I could see how it could be really good for us, but at the same time, I can also see how it would think like, you know what? Humans are actually kind of a scab. Let's peel this off and sanitize, Humans are incredibly flawed. And there's a lot of people that would use AI for heinous stuff. So the thing, though, is that AI isn't really like a love child, Birth is coming? Yeah, it's inevitable at this point. 8 billion people, right? There's going to be some people out there working on it no matter what the regulations say. I would not like to live to see the day where AI controls our life, though. Like, I bought land and I like to go out there. It's in the middle of the forest. I don't always prefer to be away from technology, but I definitely feel a lot more comfortable not being completely encapsulated by technology, you know? Um, like I work at a computer a lot of the time, but I don't know. I like having the control. And then there's also like the AI that's coming out right now. It's not actually AI, but like it's writing books, it's making art, stealing stuff from other people. Like that kind of stuff I think should be regulated. But I think like AI algorithms to figure out like, oh, what's best for the crops this year based on patterns that AI has figured out. Like stuff that improves our life, I think would be very helpful. Having dangerous jobs being automated by machines and regulation and global cooperation, 100%, they are essential. It's just really hard to get all the countries around the world to agree on anything, from human rights to AI to what you should be allowed to eat. Religious freedom and whatnot. It's really hard for humans to agree on anything at all, period. And that's why I think humans will ultimately be their own destruction. And I'm not saying like, oh, we need to take over them and all make them think one thing, because that's just unrealistic. I just think that we've expanded so much as a species that we are ultimately going to destroy ourselves. I truly think that is the future for humanity. I think we're going to destroy ourselves. Earth will survive. Earth doesn't care about us. We're just pimples at the moment. You know what I mean? Like, Earth has been through so many mass extinctions, and guess what? It bounced back, baby. So I don't think we gotta worry about the Earth. We gotta worry about ourselves.